So, as Rick said, I'm leading us into our section on associations. Again, some of this is going to be repeated from sort of the earlier slides you've seen. We're using it really try to hammer home some of these points, these core concepts, things that are integral to the functionality of the utility network. I'm going to lead you through a handful of slides, 10 to 15. They're going to get pretty deep and technical to start with, and then we're going to lighten it up a little bit, talk about a bit more high level, and then I'm just going to spend a whole bunch of time walking you through using associations in the Pro app itself. I'll show a little bit of what the REST calls actually look like when we deal with these associations. And yeah, we'll have a little bit of fun with it. So, who wooed me? I like that. So to start it off with. So we're going to start with a little bit of an overview here. Then we'll get into the types of associations that we support. The last part here, which says adding associations, configuring, modifying, viewing. I'll briefly touch on configuring, because it's not a very good demo to watch. But the rest of the adding associations part, modifying, working with them, viewing them, I'm just going to show you in the Pro app. It's a little bit more understandable, a little more connected when you see someone actually doing it with the data. So, what are associations? So, a lot of people here are familiar with the old geometric network. Connectivity was only established by XY coincidence. With the new utility network, as was brought up at one point and will be shown a little bit tomorrow when we get into the topology, it's now three-dimensional, so you have X, Y, and Z connectivity. I am Canadian, I apologize, but it is a Z, not a Z. And besides that, we have associations. And what associations allow us to do is create some interesting relationships and information within the utility network itself that can be pulled out by the users depending on what it is they are specifically interested in. Oh, okay. So there are three types of associations that we're going to get into: connectivity, containment, and structural attachment. And we're going to talk a little bit about a field, which is association status, that comes into play here. So, the reason for these associations, or one of the things we've done with these associations, is we try to enforce referential integrity. So what we're trying to do, so this is sort of the deeper technical side of it all. We built APIs, we built functionality, we built tools within the Pro app to try to protect you from creating information within your utility network that is wrong. Obviously, we can't 100% protect you all the time, but we try to wherever we can. So you'll see it as I go through some of the demos. I will intentionally try to create some bad associations, and you'll see the errors that we get and sort of the user experience of how you handle those cases. But we did build all of that intelligence at the lowest level. So if you come through the SDK, through the REST endpoint directly, through the Pro app, and you give us associations with bad information in them, instead of writing them into the index and then having to tell you that they might be bad, we just prevent you right up front with an error message letting you know that they shouldn't be in there. Now, if they should be in there, you have a different analysis to undergo. You might have to add a new rule. You might have to reevaluate the rule base in your network because perhaps something was missed. So when we create these associations, where do they actually live? This is sort of for anyone who ever has to support this thing and try to figure out where these go when you create them. There is a system table called UN underscore. The number sign in there is the dataset ID of the utility network itself, underscore associations. This is the table that stores all associations: connectivity, containment, and structural attachments. There is no unique table for each of the individual types of attachments. Although we deal with them differently, I'll show you where in that table it's actually keyed off of to determine what type it is. And there is no geometry in this table. So this is sort of analogous to some of the old GN, or the old GN system tables, the network dataset system tables. It's just a utility network system table, allowing us to harvest and store all of that association information in one steady location that can always be referred to by the utility network itself. By storing it in this table, it also allows us to forego using relationship classes, like people used to do with the GN, building up some of these containment hierarchies, things like that. You'd have to build embedded relationships in order to make those things work, and a lot of time it was just so that it would display on a map. Now, because we're actually bearing it right into the utility network, we can harvest that information through our topology, and in a much more rapid way return that information back to the user. So what does the table actually look like? It's pretty basic. Has a from network, has sort of the from and the to side of any relationship. The information stored is a network source ID, global ID, and terminal ID. If the feature being stored doesn't have a terminal or terminal information, that value will be 1, the default terminal ID. So the first thing we can see is that we have change tracking is on all of these tables. Every one of the system tables is going to have it. It's part of the contract of branch versioning. In order to enable it with branch, you have to have all of those fields enabled. You can then get that association type. This is where we're going to key off of to know if it's in connectivity, containment, or attachment relationship. And then we get our from network source and our from information. And as you can see when I click through these, what it's giving an example of is if you were to connect a fuse to a transformer, the information there is the source ID links back to the device feature class. The from the global ID refers to the feature itself. We don't have to store asset type, asset group information in here because a global ID gets you to the feature. The feature has that information on it. No reason to double store all of these things. There could be an argument for faster lookup, but there's no use case to that point yet. And the last field we have there, now this field is only applicable to containment associations, and it is a is visible property or visible containment. The idea being, and you'll see it when I get into the map, I'll sort of point this out, a properly configured utility network map, such as one that the solutions team would provide you or a business partner would provide, will have display filters set on them. So you're not always seeing things that are content. You're not always seeing things that aren't content. However, this visible content can be keyed off of to say is there certain assets that although they're inside of something, maybe inside of a substation, it's key circuit breakers, key subnetwork sources, things like that that you want to see at that highest level map. By us storing this information, it allows those display filters to be highly configured to present that information appropriately to the user. So, with the way that we store associations is whenever you start establishing these associations, we have a field that we've put into each of the feature classes in your domain network. As we said, how many do we get with each domain network? We get 5 of them. So in each of those classes, we're going to have this association status field. This is a system maintained and edited field. So the user doesn't go in there and say, I want something to be content, so I'm going to flip this to content, or 4 on that coded value domain. You simply use a tool, or the REST API, or the SDK, to create that containment association, and then we edit those fields, we edit this field in those for those features to indicate what it is. Is it content? Is it a structure? Is it attached? Is it visible content? And this is the sort of domain built of the combination of all the different things you can have. Something could be both content and a structure, something could just be content, etc. And this is that field that helps drive the display filters as well. This is where you can start to just key off of, is the value 17 in this case, in which case it's both visible content and a container. So depending on how you set up that display filter, it's probably something you want to see at all times when that asset group or asset type is visible. So you can see that whenever we create these features, we have that field, and it is automatically populated as you start to create associations. And I'll demo that as we go through this, so it's not totally a baffle as to what exactly is happening there. So now we step up a little bit. So what are our association types? We have connectivity, containment, and structural attachment. So to start with our connectivity associations, this is just the ability to say that two things, while not geographically coincident, are in fact connected to each other. The connectivity associations are junction-junction connectivity. So you're not going to say that this edge is connected to that junction that's 14 miles away, but you could say that these two junctions are connected. That connectivity association can be right down to the terminal, saying which side of the device you are actually connected to. However, if a device does not have a terminal, it can still be in a connectivity association as long as a rule exists that allows that. So this is the little graphic over there. For anyone who didn't see it, we just had a little gray dotted line show up that symbolizes that connectivity association. And again, I'll demo that as we go through this. So I'm sort of blowing a lot of these concepts by pretty quickly, but you'll see as I demo them, it'll hammer it home a little bit better, I think, than just going through these slides. Just want to give you enough context so that when I start to demo it, you're not completely lost. Everyone's sort of on the same page. And then what this is this is good reference material. This is in the slide deck. I show it up here. It's essentially constraints within the rules. So you could create in your network rules to connect certain things, but we're only going to let you create a junction-junction connectivity rule between junctions and junctions. So junctions and devices, or junctions and junctions, or devices and devices. It wouldn't really make much sense for us to allow you to start creating these rules across outside of the patterns that actually are supported. So the green boxes are the supported areas for these type of associations. And you'll see connectivity is sort of the most restrictive. As we get to the other ones, they become a little bit more of a scatter shot along the plot. So our next type is containment associations. So only structures and assemblies can be containers. And you have to, when you set up a container, and you'll see this with structures as well, you set up something called a deletion semantic. It indicates what's going to happen when I go to delete the feature, which is a container. What happens to the stuff that's inside of it? Does it also get deleted? Does it error on you and not let you delete that? Or does it actually just remove the connectivity, the containment association status on all those other features, but get rid of the container itself? Oh, excuse me. And then what this slide is supposed to show is that, and you'll see the graphic there is going to start to show and display stuff, that because we have this association status, and as I've been describing, with correctly configured display filters, you can make things turn on and off. This graphic is just supposed to indicate the sort of what it would look like if you had containment turned off, and then what happens when you turn it on. The whole map doesn't change. It doesn't alter your symbology. It doesn't change things. All it does is display the things that previously were not being displayed because of that filter. And then that's where that visible content comes into play. So if you have those display filters configured correctly, and something is set to visible content, it should always be visible, whether or not you're in a containment view or you are just looking at the overall map. Once scale suppression allows that type of feature to display. And then this is the scatter chart of where you're allowed to have containment relationships. So you can have assembly, structure junctions, structure lines. We do support linear containment, the idea that ducts could have lines within them. And then also structure boundaries can contain anything. So sort of the idea of being able to draw the footprint of a substation and say it's an open air substation, so it actually does have poles inside of it. It has pretty much anything inside of it that you could imagine. And our last type is the structural attachment associations. This is where we could say that things are attached to each other. Now, attachment is an overloaded term in Esri's vocabulary as it is. So that's why I try to always say structural attachment and not just attachment, because I'm not hooking pictures up to this pole. I'm actually hooking a transformer up to this pole. But it is something with verbiage to just try to remember to keep straight. When we speak of attachments within the utility network, we are usually speaking about structural attachments, how structures and devices connect to each other and attach to each other. And this is a much more restrictive sort of area you're allowed to define these rules. Essentially, structured junctions can have things attached to them, be it an assembly such as a transformer bank that contains transformer devices, or the transformer itself could be hooked up to the pole. These sort of things are defined by those rules. So this is the sort of quick and dirty process to adding associations. The first thing you have to do is configure. So as Rick pointed out in his as well, whenever you start changing the configuration of your network, be it adding a new asset type or asset group as a structure, as a container, adding terminal configurations, things like that, it always has to be accompanied with the appropriate rule configuration. So if you're going to go and set something as a structure, okay, you've set it as a structure. It doesn't mean anything can attach to it yet. You have to go and set up that rule base to tell it what can actually attach to this type of thing. It's always a two-step process with any of these configurations. You configure the nuts and bolts part itself. So in this case, assigning, if you can, I don't know if you can see my pointer or not, but the pole of a wood type as a structure, or changing its deletion semantic to restricted. That restricted means that if I try to delete a pole that has something attached to it, it will stop me. It will error on me, telling me I've been restricted from deleting it because there's something attached to it. And then once I've set that pole, doesn't mean anything can attach to it. Still got to go set the rules up to say what can actually attach to that pole. It's a very key part, because some people at some point are going to run into this, where they're going to set up a whole bunch of containers, content, structural attachments, and then wonder why the tool keeps erroring at them. Why is there no valid thing that can be attached to this pole? It makes sense. I set it as a structure. What's happening? A lot of it is going to come down to that rule base not being complete, or being not filled out when a change was made. Then we add our associations using our modify associations tool. And again, there are SDK REST endpoints that can also add those associations. And then we finally have the way to visualize them using our view associations button, which Rick demoed very briefly within the Pro app itself. So the last bit I'm going to cover is the configuring of these associations. So there's two key bits in here. You pick your domain network, you pick your feature class, you pick your asset group, you pick your asset type, because all of these things are defined right down to the asset type. Nothing is defined up at the subtype level like it used to be. It's all one level deeper than that. And then once you pick that asset type, now you can set the role type. Role type is either structure or container or none, if you don't want it to be anything anymore. And then you also have to pick your deletion semantics. And the three options are either restrict, meaning if it's a container and I've set it to restrict, I can't delete it if there's things inside of it. If it is an attachment and I've set it to restrict, I can't delete it if there's things attached to it. Set to none is a little bit of a tricky one to understand. What it means is that if you take the thing, the container, the structure, in this case the pole, and you delete it, and there are things attached to it, or there are things contained within it, depending on which you're doing, their association status gets set to none, the association records get removed, but the features themselves aren't touched. So perhaps you're doing a swap out of a switch gear cabinet or something, a cabinet, but all the stuff inside is staying the same. You're literally just pulling it out, switching the thing, and putting it back in. Well, you don't need to switch all those assets out. A set to none category would help you with that. You delete the overall thing, put a new one back, and create the new association records to set that up. And the last one is cascade, and this is the idea that I'm going to delete the container, the structure, and everything attached to it is going to get deleted as well. So maybe you have a rule in your utility, a transformer bank, whenever it gets replaced, all the units have to be replaced. Well, that would be an appropriate place then to use cascade, because if you're deleting one, you want all of them to be deleted. You don't want an editor accidentally leaving things around that shouldn't be there. But it is a crucial subtlety to be aware of, that you can end up deleting things that you may not be aware of if you have these set up incorrectly. So it is a very key thing for people to understand. And our last on configuring. So you can configure all of these association types have their own set of rules. So within the utility network property page, there's a different section for each of those rule types. So that's where you can go and quickly check, did I actually create these rules when I configured it? And again, the key to this being you have to add rules after you make any of these configuration changes. So in summary, associations allow us to create connectivity through non-coincident features, specifically junctions and other junctions when you don't want to draw an edge between them. It allows us to establish containment as well as attachments without creating a whole bunch of relationship classes the way we used to have to do it in the GN. By burying that stuff right down in the network topology, it means it's also ready for quick and easy retrieval during trace operations or during use within the map. And of course, the last benefit of this is that it integrates well with the display filter functionality in ArcGIS Pro to enable the building of these rich maps that as you zoom in or out or you change your display choices, you can make fewer or more features display on the map so that it gives the users an effective and streamlined strategy on how to approach their work on a day-to-day basis, depending on what it is they're doing. So now we get to jump to the demos. So I'm going to open up ArcGIS Pro here. You can see that I have, hopefully everyone can see. I see there's a bunch of messages there if anyone wants to take a look in case there's a question milling around. So you can see I'm looking here at the red trolley data. I've got a bunch of bookmarks set up. So to start with, I'm just going to navigate to my little association demo area. So you can see in this area that I'm looking at, I know that off this transformer, there's probably things connected to it, but I can't really tell what's connected to it. I need sort of that first level look of what it is that I'm actually, what it is I'm interested in. So there's a couple ways you can view associations. You could open the Modify Associations tool, click the Connectivity tab here, and select the transformer itself. Oops. And get an error message. So that error, what it's actually telling me is that I am picking a transformer bank. The transformer bank does not have connectivity associations. Another place that this tool is trying to help you. It's not going to let you just pick anything and put it in this tab for connectivity when it itself has no connectivity rules that could be established in it. So the way that we can handle that is I could zoom well in further to the actual transformer itself. And then when I click on that guy, if I could click on that guy, there it is. Now I see the transformer, and I see that it's connected to an elbow. Now within this pane, what you'll notice is that below each of the asset groups, there is this bolded information. In my case, it says 103. That is the display field configured in my layers being displayed in that pane. I have displayed mine based on subnetwork name. I could easily display it based on asset type. I could display it on some other meaningful bit of information. And you could configure each map to have a different display field, depending on whatever it is that you want that user, that experience, that role to see in this type of an environment. And then it will display here. The key being that this pane is responsive to whatever you've picked as your display field in the map itself. So you can see on the high side of this transformer, there is an elbow. If I flip to the low side of it, now I see that there's a whole bunch of service points connected. So I say, okay, well, that's what I thought I was going to see. So, but then I say, okay, but which actual service points are connected to this transformer? So the easiest way to get a quick visual representation of that is to click the View Associations button right there. Now, it tells you in the upper right in this little toast how many associations were returned, in this case 59. And then I can see them. Now you'll notice I can't select them. There's no interaction with them. They are just a graphical representation of the associations that are currently visible. Now, on this little options pane right down here, you can configure what it is you are viewing. I could turn off connectivity associations, so I'm only going to view the structural attachment associations. Perhaps I can't remember what I attached to this pole, and I don't want to go through this pane because there's just too many things in there. Well, I could just view my structural attachment associations, close this out, reset the view, and then only those associations will display. Now, one of the other little interesting doodads of this is if you limit the number of associations being returned. So let's say you're in an extremely dense area and you know you're going to have 5,000, 10,000 associations returned. Well, there's a hit to that. There is a performance cost to generating those graphics for the client. You probably don't want a client doing this in a place where they're going to see 5,000 associations. They're going to see so many dotted lines, they're not going to know what to make of them, heads or tails. So by limiting this value, you can restrict it to a much more reasonable amount for the person to be exposed to. So in this case, I just dropped it to 50. And what's going to happen now is nothing is going to display for me. And this toast is going to tell you why. If you remember from before, I actually have 59 associations within this extent, which is why none of them show up now, because I set that limit to 50. It's just an option so that you can toggle so that you can get a little more smoothness and not put yourself into a corner where you end up with bad performance trying to view these things without fully understanding why it is you're running into that. So for the purposes of this demo, I up this back to 100 so that I can see them, turn it back on, and now I see my associations displaying again. So that is the primary way that you interact with associations which already exist. You essentially have two ways to view it. You can either view them through those graphics that can be drawn at demand time, or you can use the Modify Associations pane. Now within this pane, you can right-click things that are in the lower half, and you could say Modify Its Associations. So now it becomes the primary, and whatever is connected to it becomes the secondary part of this. Then I could start to flip what it is connected to. One key bit to take away, you'll notice when I picked a service point as my connectivity feature, and then I have the transformer, I cannot pick the high side of this transformer. You might say, well, why? We know it has those terminals. It is because this pane draws in the rules in your network. There is no rule in my network that the high side of a transformer can connect to a service point. Therefore, we're not even going to present you the option. If you went through the REST endpoint, if you went through one of the other access paths, you could enter in the high side here, and you would get the error from the API. Because we have access here to tools and things that the user is interacting with, we simply protect you at the moment you are doing your work, so you don't have to eat the cost of trying to send it across the wire just to find out that you had entered something incorrectly. Wherever we can protect you, we will try our best to protect you. So, we're now here. We've now been able to view. I'm going to turn off that viewing for now. And now I'm going to show you the different semantics and what that means, all of our three different semantics. So, we start with our set to none. So in this case, I have a poll. You will notice that if I try to use this connectivity tab and click the poll, I'm going to get an error. That's, again, because we're trying to protect you. We're not going to let you load up the poll into a tab on this pane where you're never going to get to click apply. Or if you did click apply, we'd have to error at you immediately. So I click to my attachments. Now it says kindly to me, select a structure. So now I'm going to go pick that poll. And what you'll see is there's three things connected to this, two guys and a connection point. So I can delete this poll. And what's going to happen if I delete it is, let's say I was to select this guy wire, and I look at its attributes. Right now, its association status is set to attachment. Based on the fact that I told you that the poll's deletion semantics was set to none, we know if I delete that poll, this is going to get set to none. So we can prove that fact by picking the poll and deleting it. And you'll notice I get a whole bunch of little dirty areas here. The reason you don't get just the dirty area for the poll is that all of those associations that we just had to modify, we had to remove those three associations and modify their destination features association status to be none. Each of those edits, the removal of the association, generates its own dirty area. I'll get into this a little more tomorrow as I talk about the topology itself and validate, but that's just to clear up why it is that there's more than one dirty area showing up there, because that always seems to confuse people a little bit. Why did I delete one thing and I got 4 dirty areas, 5? And remember, the more things related, especially if you're allowed to delete them, the more dirty areas you will see. So now if we go back and look at the attributes for this guy, for the guy wire here, you'll notice that now its association status is in fact set to none. And that's what that set to none semantic gets us. Now I showed it with an attachment, a poll to features. The exact same applies if that was a container. If it was a substation that contained some things and it was set to none, it would do the exact same thing. The only sort of catch there, and I'll show it when I get to one of the containment examples, is that because the association status gets set to none, my display filters, which filter out anything that are content, will now start to display those features. They will allow them to be drawn on that map. So, for the purposes of this demo, I actually undo that edit and show you that it goes back to attachment, and undo does actually work. I am working in a named version right now, so I could be saving things and validating, but for the expedience sake of this and the fact that topology is tomorrow, I'm just going to undo a lot of these edits as I go around doing them. So now let's show the next deletion semantic, and this is the cascade semantic. So this is the idea that if I delete a container, everything inside of it gets deleted as well. So I have some cabinets here, and I know this cabinet is a container. So if I go look at its association, again, I can pick that cabinet and see all of the different things that are inside of it. If I start to zoom in, you would see that there's a little more detail coming in, but still not much. There is two ways that I can make this display more detail of that cabinet. I can either say display content. So this display content button toggles on or off the display filter that is applied to your layers. If you don't have display filters on your layers, this toggle doesn't do anything. It only toggles on and off that display filter. So don't think it's a magic button that just knows everything there is to know about your data and will miraculously always work. So in this case, I want to show that content. So now you'll see that all of the little intricacies and details start to show up. Now, this cabinet has a cascade delete semantic. So if I delete it, you are now going to see a whole bunch of dirty areas show up. You get one dirty area for the cabinet I deleted, one dirty area for all of those other features that were inside of it that got deleted, everything from this list, and you get one dirty area for each of the associations that we had to remove. So that's why when you do something like this, you see a plethora of dirty areas. Mr. Brown.
I've got a question.
Of course.
Where did that delete of all those features that were contained take place? Was it the client application that needed to delete them?
Oh. All of those deletes happen on the back end on the server tier. We send across the delete call. The server handles all of that work. So you're not sitting here as a client sending across 150 different delete calls. In fact, I could, I'm not going to do it right now. I could show you Fiddler where I could show you that delete call actually only sending one apply edits call across the wire. And it's a function called return service edits that lets us know that that call made other edits that resulted in a cascade of features being edited. In this case, many, many things deleted.
So probably a related question, but when you're doing everything here in Pro and doing things like view associations and then you can see the dirty areas and things like that, would you have the same experience in a web browser or on a mobile device? Would you have that all the same options and functionality? So
the question was, in Pro, as I work my way through here and I'm deleting all these features and I'm seeing dirty areas display and I'm seeing all of this cascading behavior, things like that sort of advanced deleting behavior, would I see that same functionality and behavior if I was working through a web app, a JavaScript app, whatever it has? Yes. Yeah.
Do you have the capability of viewing associations?
No. The view associations tool is a specific graphic tool we built into ArcGIS Pro. You could author something in one of those other apps to do such a thing, but no. There is no out-of-the-box view associations tool for all those other places. For the modify associations pane, that is a Pro tool only. If you were off in a JavaScript app and you wanted to have someone build that, they could, but there is no, it's not a portable tool that we built that goes anywhere. Mr. Brown.
The developer online wanted to remind the group that to get those associations is a call to a REST endpoint. So you can easily write your runtime app, your JavaScript web app, just to call that. All it takes is an envelope as input, and and a ceiling that has number 200, where the threshold is. It will return you all those as feature geometries, and you can then render in your application. So everything you see Pro does is hitting all the rest endpoints. Nothing that we're doing that any other developer can build off the service.
Annie, you are welcome to speak up at any point that you want.
You're rocking it, Dave.
How appropriate. So for the sake of this, again, I will undo, and you'll notice, miraculously, everything comes back. All my dirty areas go away, and I'm back to a good state that I was in before this. And the last one of these little semantics that I'm going to show you is the restrict semantic. So in this case, I have a substation boundary. As you might imagine, you probably would want to set most of your substation boundaries to restrict, because odds are you don't have editors going around and just deleting substations. I would imagine that that would be a pretty dicey situation you could get yourself into pretty quick. So in this case, if I was to select this substation, and again, we can show it the same we've been showing. If I grab the containment tab, click on my container, I can see all of the stuff that's inside of it. Now, there's a whole bunch of subnetwork controllers in here as well. So if I was allowed to delete this thing with like a cascade, you could imagine the ripple effect that would have on your overall functionality of your network. So if I grab this guy and I delete it, you'll notice that I get this extremely nice and pretty error message, which informs me that it is unable to complete this operation. You ignore this sentence, and then it says the feature participates in utility network and has existing association records that must be removed prior to deleting the feature. So the first and the last sentence are very helpful in that error message. Now, if anyone wants to know where to look to see what my deletion semantics are, I sort of jumped right into the demo part of it, and now I'll show you how to figure that out. If you look at your utility network properties page, and you go down here to the actual network. So let's say I was looking at my structure network, and I went to one of my structure junctions, and I went down to my poles. My poles are structures, as it says right here. That's that role, that association role that that asset type can have, and its semantic is set to none. That's why when I deleted that pole, the things connected to it stayed put, but got that association status set to nothing. If I look at some other things, for example, a cabinet fuse is the type I was using there. It has that cascade delete semantic, so it will try to delete anything inside of it. There is one caveat to that. If you have a cascade semantic, but the feature contains a subnetwork controller, you will get an error. It will not delete the subnetwork controller. There is a different workflow to get rid of that controller. It is not using the cascade delete semantic on the controller. And the last one that I had shown you was this substation boundary, which has that restrict parameter. And that's what defines that all that deletion behavior that I was showing you. Now the next one that we're going to show you is how to create an association. So there's a couple different ways to do this one as well. So the first one, we go back over to our original area. Now, I know that this transformer, actually transformer bank, hangs off this pole. So I say, okay, well, I should check, is it already there? So I look at the pole, and I notice it has nothing attached to it. So I say, okay, well, I got to fix that. So I click on my transformer bank. Now, you'll notice that it gets dropped in this pane, but you'll notice it has this asterisk beside it. The asterisk tells you that it is uncommitted. It is in memory, within this pane, it is there. And if you click the apply button, it will work, it will go through. But there's no REST call being made until you click that apply button. This pane is not a chatty pane that just constantly is querying at this REST endpoint. It makes you interact with it to say when to fire it off. The reason being, let's say I wanted to add 100 things into this piece of container. I don't want it to fire off 100 different REST calls every single time that I go to create it. I want it to populate the pane once, bundle it up as much as possible, and then make that call across the wire. Remember, because it is services based, you have to always consider, that's interesting. You always have to consider what the implications are of what you're doing. The primary reason, so we've written these tools to be smart within Pro, try to help you out. Someone starts writing JavaScript apps that hit the REST endpoint directly, they could do this in a very inefficient way. So understanding how these things work and trying to bundle them up is a very key bit, especially as you start to deal with customers and they come back to you and say, I wrote my JavaScript app, I try to create containers, and it's extremely slow. These are the kind of things you have to start digging through. Have you grouped up your things? Have you tried to mimic what our tools do to be as efficient as possible? Once I click apply, you will see that asterisk go away. And then if I was to click the red X, it's the same principle. It doesn't delete it until I click apply. It puts a strike through to let you know that you've done something, but it doesn't actually commit it until you click apply. I could also hit this refresh. Now it's going to tell me, hey, you've done something on your pane. Do you want to save that edit? In this case, I don't. I didn't want to remove it. So when I hit that refresh, it'll now put it back into the state that it's actually in the software. This pane reads the associations table directly. It does not make network index queries. Why that is important? I have not validated this network since I added that association. But this pane tells me that association exists. The reason it doesn't have an asterisk is there is a real record in your associations table for that piece of attachment to be there. Until I validate, though, things like if I was to trace this part of the network, it wouldn't know if I said include structures, it wouldn't know to include that poll until I validated. Because the topology does that work. So there is a bit of an understanding you have to have that this pane drives directly off of the table, not out of the index. So in this case, now that I did that, I can validate my topology. You'll notice it is theoretically much faster than Rick's. Theoretically being the key. And then we get this little toast that says validate successful. I'll get into that toast tomorrow as we talk about topologies more. Okay. Sorry, I just have to make sure I touch everything before I. And the last thing I'm going to show you is linear containment. And I'm going to show you the containment view in doing my linear containment. So if I go look over here at Old Town Substation, you'll notice that at this view I have a lot of really thick symbols. Well, these light blue things are all ducts. So they contain lines. Now you'll also notice that my map looks a little bit like it has all these dotted lines all over the place. Well, you remember earlier in one of my demos I said to display the content. I never turned that setting off. So if I was to zoom out and start looking all over the place, you would notice that my performance would not be as good as when I originally opened this map doc. And it's because I'm displaying everything right now. So I want to go back into my hiding containment mode so I can only see all of the things that I intended to see in the map at this scale and at this point. I can zoom in a little bit, and I can grab this duct, and I notice it contains 3 media voltage lines. Because of the way that I'm not displaying content, I don't see the lines. So I don't know which one is which. So let's say we have this mode called containment mode. So by clicking the enter containment button and now selecting that duct, that linear container, it does what's called entering containment mode. So now it turns off all those display filters. It zooms me to a scale set on that type of container. In this case, because it's a substation, it's a pretty big scale that it leaves me out at, which is why I see a lot of things. But I could zoom in here a little bit and focus in on these 3 lines, 1, 2, and 3. So these 3 lines are the medium voltage lines referred to here, and we can prove that by right-clicking one and saying flash, and we see it show up. If I was to remove one of these from here and apply it, and then exit containment mode, what you will notice is that despite the fact that I don't have my containment being shown anymore, that line is now visible. It is visible because it is no longer content. We set that association status to none. It's no longer content. which is why now it is visible at this top level, despite the fact that I have a well-configured map with display filters. So I could go back into containment mode. And the last thing I'm going to show you is what happens if you try to contain something that can't be contained. So when I'm in containment mode, what does that really mean? What it means is that if I start digitizing any features, it is going to put them as content of whatever containment I have activated to get into containment mode at the moment that I edit it. So it saves you the step of having to go and say, okay, I'm creating this substation, I create all these features, and then say, now contain them all within it. Instead, I could create the substation, enter its containment mode, and then just digitize features normally. They would automatically go in as content. And I could probably get away with creating one. We'll see if I can figure out the correct line type to put in here. So I think it's one of these guys. And you'll notice, because I have a well-configured map, every time I click, and you'll notice it a bit more tomorrow as we start to go through some more editing demos, things like that. Whenever I click one of these templates, I get asked a question. Or essentially it's this is crucial information that must exist on these features for them to be beneficial to the system. You can configure your templates within a project to present whichever fields you feel are important. So if I was to go here and digitize a line, and cross our fingers that it works. So there it is. And you will notice if I look at the attributes of it, it is marked as content. I didn't set it as content. I didn't create associations. Because I'm working in that containment mode, it is automatically being set to content. That could trip people up a little bit, especially if they think they've entered containment mode and they haven't. Then they're going to wonder why it is things aren't going in as content immediately. Something to be aware of. And last but not least, what happens if I was attempting to put something in here which doesn't belong inside of here? So this is a duct. Odds are that trying to stick a wood pole in the middle of that duct probably wouldn't work too well in the real world. So what happens if I try to do it? Because at the moment I create that feature, it allows me to create that feature. Okay. That duct apparently has every kind of association available. So we're going to pretend like that didn't happen.
Are you sure you're not in the substation?
I might be in the substation now that I think about that. Let's find out. That's a very good question. So if I was to exit containment, and then be very careful that I make sure to click on the actual duct, it requires some extremely precise clicking. There we go. So now I'm inside of a duct. I wonder what happens if I try to create a substation. There you go. So because I'm inside of a duct and the duct cannot contain a substation, you get this, again, very informative and helpful warning that tells you that it was unable to create this feature, the containment association is invalid, and that is because at the moment we create the feature, we are also creating that association record.
Is there any way to know what container you're in?
So the question was, is there any way to know what container you are in when you enter containment mode? Annie, is there a way? I don't believe
The pane should switch automatically to show the container. It should load the container that is in containment mode.
I can't hear.
Can you hear me?
They can hear you at some point in the room, but I can't hear you.
Okay, I'll put it in the chat window.
So I don't believe there's a way, but I will wait for Annie to type it in, and then I will tell you if there is. Oops. Oh, they can hear her online. Well, that's very nice. The pane should switch the container that is to the container that is in containment mode. So the modify association should be set to the container, which I have entered containment mode for. That's how you can tell. And the last one I'll show you just for fun is, so I'm in this one. We saw that I removed this piece of content. So now if I add this piece of content back, but let's say this time I want to add it as visible content, and I apply that, what that means is that when I exit this containment mode, and then I zoom back out and I have my content not displayed, I will still see that edge. I will still see that feature because I've explicitly set it as visible content. And I am out of containment mode. And you can see I can still see that feature. If I click it and I look at its attributes, you'll see that it is set as visible content, which is why I'm able to see it even with those display filters set. And that is the Firehose version of associations and how to work with them. Any other questions? I take crickets as a good sign. Oh, I got one. Okay.
When you were doing the first demo of
Mm-hmm.
and you deleted the poll, it changed the attribute on the it also created the area for those.
Yeah, it does. So the question was, in the first one I did when I deleted the structure, the poll, and it had attached things, and the semantic was set to none, did it generate dirty areas? And the answer is yes. It removes the associations, so therefore it creates dirty areas for each of those, and then it does not create dirty areas for the actual other features, because that field is system maintained. Am I speaking incorrectly? Based on the look of Tom, it creates a dirty area for everything being edited. How about that? There you go. Alrighty. Oh.
The display, so one of the semantics was something that popped back up out of the display. Is the display filter set by the association or the properties of the network?
The display filter is set layer by layer within the map. So you can set it to be based on whatever you want. We've set up our display filters to be based on that association status field. So it's a big, long, if it's visible content, always display it. If it's not this or that or the other, then don't display it. And that's how we draw that in. But it's all individually configurable within the map that you're working in. The question was, can I have containment within containment? Yes?
So, let's show content. Show all content that's within container.
It'll show everything, because it'll turn off the display filter. Unless you've set up your display filter to be very smart to say only show content and not container and content. Cool. Thank you.